Hey guys, this is Srini and you're learning about the basics of Python on my channel Python for Microscopists on YouTube. Again, these videos are intended for beginners and I keep saying this in every video. This is for students, researchers, or anyone who's interested in learning Python, especially with the focus on image processing. Now, in today's tutorial, we're going to talk about functions. And functions are a convenient way to modularize the code. This makes it easy to reuse parts of the code. For example, if you want to load an image, if you want to rotate the image, or if you want to perform some sort of an operation to this image and save it. Now, you can write a function for this specific task and call it whenever you want. And sometimes outside of the same program, you can refer to this program and you can call this function. That's exactly how we use the print function, for example. Let's jump in then. You define a function by, let's get back to our Spider interface. You define a function by typing def keyword and a name of your function. Let's just say my function, and then you put these brackets, and again, just like a for loop or a while loop, you end this with a colon right there, which means when I hit return, everything part of the function is indented under this function. So now what do I want in this function? Let's keep it simple. Then let's just say print hello from inside the function. Okay, so this print statement is part of this function. Now, if I go back outside, now I'm outside the function because I'm not indented anymore. So from outside the function, I can call this function. Okay, so now I can basically say print. I don't need to do print. I just do my underscore function and I do this. So whenever I type this, when I execute it, you would see that the function gets executed. Whatever is inside this function is written down here. So this is step number one. Let's actually explore this a bit further. So a function, you can actually give arguments. Right now here it's empty brackets because there is nothing inside. You can actually pass some arguments in here. So we can just say your underscore name. Let's say what the parameter that this function takes is your name in this example. It can take any number of parameters depending on the nature of the function. So let's just print, let's say your name is, and your name. Okay, and now my function, I cannot just leave it empty. In fact, if I run it, it's going to say missing one required positional argument, your name. So it's expecting me to pass something. Yeah, so under my function, I'm gonna just type my name here, and when I run this, you should see your name is Srini. Now I can call this function any number of times. I can call this function again. In fact, I can update what I have, or I can call the function again, and I can just say Srinivas, for example. So when I run this, I should see your name is Srini, your name is Srinivas. So a function can take arguments, and you can also define a default parameter. For example, if the user doesn't want to pass a parameter in there, then you can actually enter a default parameter. For example, let's just say my function, and let's write a function that says, okay, my country, yeah? So country equals, let's say, USA. Okay, so this is the default parameter because I just put equal to, and then I defined USA. So if the user doesn't enter anything, in this case, we saw that. If we didn't enter anything, it yelled back at us and saying it's missing one required argument, supply this argument. So in these cases, a good classic case I can think of is if you're performing some sort of a smoothing on your image. And if you supply a default argument of whatever the extent of smoothing, let's say the kernel size or something. If you supply a default parameter, then even if the user doesn't enter anything, or you doesn't enter anything when you're running the code, then it uses the default value. Otherwise, it's going to come back and say, hey, enter this value. So country equal to USA. Let's say I am from, and let's just put plus country. Okay. So in this case, it's going to print I am from and add whatever that country is, whenever we call this function. So if I just call, let's delete this second line. If I just call this function without putting any parameter, now hopefully it shouldn't give an error. It says I am from USA, because this is how you can define like a default value. Okay. Now, if I put some other value, if I say I don't want to use your default, I'm going to put my own. Let's say I am from India. Okay. Now, when I run this, it should say I am from India here. So this is how you can define a default value. Now, you can actually, instead of one single value, you can also pass a list of values. So let's call this function my function and food, okay, or fruits or something. And now let's iterate through a loop. And again, if you remember for loop, if you use for, you can iterate through elements in your list or in your string. So in this case, let's expect a list. So for x in we called it food. For x in food, again, anytime you use for, do this. And what do we want to do for x in food? We just want to print x. That's it. Okay. Now down here, I can actually now I'm outside the program, right? I mean, now if I'm not inside, if I'm not tabbed, if I'm not indented, I'm outside the program. So this is called the main part of the program, and this is the function part of the program. So now in the main part, let me define an array called let's say fruits or something, and my array is equal to apple, pear, and let's say banana, and this is my well, let's spell it correctly. And my function, now if I just put fruits here and run it, you should see it's going through each element and printing it down here. So this is, well, I'll do a better example in a minute, but I just want to show you that you can pass individual parameters. You can pass like a list of parameters into the function. And also, so far we're not returning anything. And normally, when when you write a function, it does some sort of a computation, and you would like it to return something, so you can use it in some other part of the function or some other part of the code. What do I mean by return? So let's just keep this simple. Let's say my function is x, and let's not do a list. Right now, my function is x, and instead of printing, let's actually return 5 multiplied 5 times this x. Okay. So when the function is done, it's actually returning a value. When I call this, it's actually returning a value that's multiplied by 5. So if I call my function again here, when I call, it does the computation, but it doesn't show us anything. So let me just print and then call my function, and the value is, let's say, 3. Okay. So all I'm doing is printing whatever the result is, and the result from my function where I pass a value of 3, and what it returns hopefully is 15. So when I run this, you should see it returned a value of 15. So I can use this function. I mean, so this is the power of functions. You can define any number of functions, and outside of the functions in the main program, you can actually call whatever function you need. So I thought of actually working on an actual image, but let's go back to our familiar example of converting centigrade into Fahrenheit, and then just define a function for Fahrenheit as a function of centigrade, or Celsius if you want to call it. And f equals to, I've already used f, so let me just call this f value equal to 9.0 divided by 5 multiplied by c. Well, let's actually do that so it's easier. Multiplied by c plus 32. Okay, so this is my f value, And now let's go ahead and print, let's put a placeholder, an integer, and call it these many degrees centigrade is equal to another placeholder for Fahrenheit, these much, Fahrenheit, I believe. And then the placeholder, what do we have? The first one is centigrade, C, and the second one is F. Well, it's actually F underscore value. Okay, so the first one is F and the second one is, the C, and the second one is F value. That's it. So we defined a function. Now let's get out of the function and let's call F of minus 40. We know it should be 40. So when I run this, see it says minus 40 degrees centigrade is equal to minus 40 Fahrenheit. Okay, so this is how you can define a function. Now let's actually use the same, and let's take a list as input. Instead of minus 40, I just want to give a list of numbers. If I already have a text file that has a whole bunch of numbers and I want them to be converted, this can be, let's not get into importing external text files and everything yet, but let's just convert this code. So FC, I would say for I in C, again, remember we need this colon, and let's actually indent this. F value equals 9/5 multiplied by, now we are iterating over I, so multiplied by I plus 32, and let's tab, and we can keep this as is, and then let's just change this to I think that's pretty much it. Now let's define a list called C. It should work, but because I've already used C over there, let's just keep things different. Centigrade equals 20. Let's say actually we could have actually done range here, but let's just do minus 40, minus 20, minus 10, 0, 10, 20, 40. Okay, so let's say this is our minus 20. This is our list. And now all we need to do is F of centi. That's it. So when we run this, hopefully it should go all the way from minus 40 to 40. As you can see, it's doing that. And this is it. So this is a summary of functions. These can be very, very, very useful in organizing our code in a pretty easy way. Now, before ending this, I would like to work on an actual image, just like we have been doing in the last couple of videos. So let's go ahead and see if we can read an image. And then let's try rotating it. Let's also try a function for blurring it, and another function for either denoising it or sharpening it or something. So let's start by importing an image. And we've been using SciPy package for importing from SciPy import. It was under miscellaneous. And let's also import another function called ndImage. ndImage, what this does is ndImage also has some tools, basic tools for image manipulation, like image rotation, and other things like blurring and, Gaussian filtering if you want to do that. A few of these are part of ndImage. Again, look up the documentation online, but this is just for demonstration purposes. Better libraries are in OpenCV, scikit image, and other packages. We'll talk about that later on. So from SciPy, we actually imported this, and now let's actually define a function called rotated. Okay. And then what does it take as an argument? It takes an image as an argument. Okay, so we are supplying an image to this function. Now what do we want as part of this function? So let's say my rotated image equal to, I'm giving a name, my rotated image equals to ndImage dot. Now when I do this dot, you can see exactly what it does. It does erosion, dilation, closing, transformation, fill holes, all of these basic image processing operations that you probably are familiar with if you use ImageJ, for example. This contains, including Fourier and a whole lot. So we're not going to use any of those right now since we are doing rotation. Let's just do rotate. I believe this is part of it. If not, it'll tell me. Let's do this and then rotate. Yeah, rotate is part of this, and let's rotate this by 45 degrees. Okay, so it takes in an image and rotates the image by 45 degrees. And once it rotates, obviously we need to save it. So if you remember, I am save. And where do we want to save it? Images slash, and let's call this, because this is rotated.jpg. Okay, well, we need to say exactly what we are saving, rotated underscore image. So this is a function that takes in an image as a parameter and then rotates that image by 45 degrees and saves it as rotated.jpg. I'm going to just copy and paste so I don't have to type all of this again. I'm going to define another function, and now let's call this, instead of rotated, let's call this blurred, and the image dot, there's a Gaussian filter. So let's just use Gaussian blurring, and for that it takes sigma equals to 5. You can look at the documentation for, again, Gaussian filter. If you just look at ND image and the documentation, I've used this a couple of times, so I kind of remembered how to what parameters to use for this specific Gaussian filter and also for rotate. So let's call this blurred.jpg, and this is going to be our blurred image underscore image, which means I need to change this to blurred. Anyway, so I just copied, pasted it here, and what I'm doing is, again, blurring with this, and let's do one more. So this gives you an idea of the importance of functions here. So now let's, instead of blurring, let's actually do some sort of a denoising. Denoised, and let's call this denoised image equals. And the function for that, there are a few ways of doing denoising, and one is we can just do median filter. Okay, that's a way of performing denoising. It kind of preserves the edges. Non-local means is a much better way of actually doing denoising. But for now, let's do this, and let's put a kernel size of 3 right there, and save this as denoised. And I just realized denoised, and then let's call this denoised image. Okay, so we just defined 3 functions. Now we can go down to our main program, and now we can actually supply an image. So now once I have an image, I can actually pick what I want to do here. I can do a combination of these if I want to. So let's just say image1, my image is equal to miss.im read. We have used this a couple of times, so you know exactly what we are doing. Images slash our image is test underscore image.jpg, and this is pretty much it. So this is the input image we are supplying. And now what do we want to do with this input image? Let's just say rotated img1. Let's say let's do all 3. So we end up with 3 images. We can go ahead and look at the 3 images. Denoised img1. Okay, so let me not explain the entire thing again. We just created 3 different functions, and each function does something. And for those, we used SciPy ND image, and within ND image, there are a whole bunch of functions that we can use, and we're using rotating, Gaussian filtering, and median filtering. So we have written these functions. Once the functions are written, we can just load any image and then just call the function. So we called all 3 functions right now. And when I run this, as you can see, it's doing one after the other. And when I open this folder, you see the blurred image, denoised image, and rotated image. Our original image is testimage.jpg, and rotated image, it's obvious, you can see it. It's rotated by 45 degrees. You can reshape it, you can rescale this and all of that, and we're not doing that for now. And that's we have a denoised image, and we also have a blurred image that apparently is converted into grayscale, and our denoised image looks different. Our channels all look mixed up. Again, that's something we can probably talk in future, how the images are read by different packages. And this is obviously our blurred image here. Okay, so this is how you can use functions, and these are very literally single line of code. And in fact, if you really want to do these in these little tasks, oftentimes it is just these single lines of code. That's it. I talked about, again, NumPy arrays and all of that kind of stuff. So if you want to do advanced image processing, you want to write your own filters and all that, that's great. But if you really want to do these rudimentary tasks, you want to perform rotate an image, you can actually say, okay, my image 2 equals a rotated image, and then take that as your input to your blurred, and then supply that to the blurred, and then supply the blurred image to the denoise. So it actually performs one task after the other, and that's how you can easily automate your image processing tasks. So anyway, let's continue with a different topic in our next video, and I hope you found this very useful. Thank you very much.